For this video, I will demonstrate how to use Stata to fit a structural equation model. And the example that I'm going to use is taken from the Schumacher and Lomax A Beginner's Guide to Structural Equation Modeling textbook. And the model that we're going to fit with Stata consists of the relationship between home environment and achievement as it runs through a spire or is mediated by a spire, and ability on achievement and how a spire mediates that relationship between ability and achievement. Now we have these in the square boxes. We have our observed variables. So we have 9 indicator variables, and these variables are divided into measuring 4 different constructs. So for example, family income, father's education, and mother's education is measuring the home environment construct. This would be considered part of the measurement model of the structural equation model, as well as verbal ability and quantitative ability measuring ability. This is part of the measurement model, as well as Aspire and its indicator variables, and Achievement and its indicator variables. The structural part of the model is the relationships between the unobserved constructs: home environment, ability, Aspire, and Achievement. So let's look at the data that we have available for this particular example. And you can see that this is the variance covariance matrix for this data. So in Stata, what we're going to have to do is create a do file. So I'm going to open that so you can see what it looks like. And if you haven't seen or if you don't know how to construct a do file when using a covariance matrix to run a structural equation model, you can look at some of my earlier videos. I've demonstrated how to do that. And so you can see that we have our indicator variables, our observed variable labels at the top. And then we have the covariance matrix here. Now, what's very important is that these are in the correct order. So the correct order in which they're shown in the diagram. So for example, these need to be in the correct order when they're entered into the do file. Otherwise, your analysis will not be correct. So let's go ahead and run this do file. So the one that's highlighted will be the do file here. And what you should see is this output on your Stata window. And if you don't have any red messages or lines from the Stata output here, then you know that your variance covariance matrix has been imported correctly. Now the next thing I'm going to do is open the STEM file. And so that's the diagram that I created earlier with Stata. And so what you might want to do is, again, review an earlier video if you don't know how to create these diagrams using the Stata drawing, or the SEM builder, I should say. And so then I'm going to run this analysis. And you can see now I get my my path coefficients between the unobserved constructs, and I get my path coefficients between the unobserved constructs and each of the indicator variables, as well as the error variances are also represented in the path diagram. So let's see how these values correspond to our output. So I'm going to zoom this up just a little bit. See if it helps us to. So if we look at our full structural model, we see that the path between ability and achieve is 0.69. So that's where we get this path coefficient. And then between ability and aspire, that's where we get this path coefficient, 0.446 or 0.45. And then the relationship between home, up here, home and ability is 0.30. That's this path. And the relationship between home and aspire, 0.51. That's this path here. Then we have aspire to achieve, and that's this path here, 0.525, or rounded off 0.53. Then for the measurement part of the model, we have these coefficients here. So this first one, of course, to get to scale this particular construct, family income is set to 1, and then we see the other coefficients represented here. So you can see where we're getting these values that correspond to our path model. And then our error variances are all listed here. And so, for example, the error variance for family income, and you can't see it here, it's difficult to see, but you can see that right there as I pull that out, that 0.19, that's representing the error variance here, 0.19 rounded off. And then we also have two other pieces of information. And oh, by the way, you can see the rest of the error covariances here on the path and how they correspond to each one of these in this part of the output. But then we have two other pieces of information. We have the error covariance between father's ed and mother's ed. And notice that little e, that means it's an error covariance. And that's 0.17. And then we have the covariance between home and ability, 0.53. And so this model is indicating, or when it was first established, that there's a correlation between home and ability. And there's a correlation between the errors between father's ed and mother's ed. Now, the other thing we might want to look at is, I'm going to close the diagram. I'm going to close that diagram. The model fit. And so if we go to statistics and SEM, whoops, and goodness of fit, we like to get the overall goodness of fit. And I usually get the root mean square error of approximation, and then I like to get the measures based on residuals. And for this model, we can see that we have a perfect fit. We like our RMSEA to be less than 0.05 or less. And so our probability of a close fit, our probability of a close fit, it's not significant, which means we have close model fit. Okay, and then a coefficient of determination is 0.968, which is excellent. That means that this particular model, and the relationship between those variables and how they're measured, is explaining about 96, almost 97% of the variability in achievement. So another piece of information I want to show you is the equation level goodness of fit information. And the reason I like to get this is because it helps us to form or understand the structural equations. So the structural equations for this model are formed by looking at the coefficients from our output. see if I can just shrink that down just a little more so we can fit all this on our on the Camtasia screen here. And so we see that if we look here, our structural equation for a spire, ability 0.446 or 0.45 if you want to round off. Home is 0.506 rounded off. So 0.447 times ability plus 0.506 times home. And then we have our prediction error that we need to include. Well, we get our prediction error from the equation level goodness of fit. And I can get that right here in this part of the Stata output. And so my prediction error for this equation is 0.317 rounded off. So that's where I get this value, 0.317. And then the r square is 0.631 if I round off. And that's where I come up with the r square. So this is the first structural equation in the model. And this is the other structural equation. So looking at the structural equation for predicting achieve. And so where do I get those coefficients? I get them from, let me just toggle up here. I get those coefficients from this portion of the output. So you can see that the structural equation for achieve is 0.685 times ability, 0.302 times home, and 0.525 times aspire. And then the prediction error comes from the tests of equation level goodness of fit. And so my prediction error is 0.227 if I round off. And so that's where I come up with this value. And then my r square is 0.862. And so my r square, 0.862, comes from this portion of the output. Now, one other thing I want to show you is that in our model, we also want to look at, let's see if I can find it here from the diagram. We also want to look at the indirect effects of aspire on the influence of home directly on achieve, and the indirect effect of aspire on ability as it influences achieve. So we can do that in Stata by going to statistics, SEM, and we can go to testing and confidence intervals, and then I can ask for the direct and indirect effects. And so this will give me lots of information, but what I'm mostly concerned with is looking at the, I've got to click on more down here. Okay, so what I'm interested in looking at are the indirect effects of home, or I'm sorry, the indirect effects of aspire as home run, the indirect effects of aspire on home as it runs through achieve, and the indirect effect of aspire on ability as it explains achieve. So we can do that by looking at calculating the proportion that's mediated. So the coefficient for the indirect effect of aspire on home going through achieve is 0.26. And the indirect effect of ability is 0.23. Now these are unstandardized estimates. And both of those are significant. So they're significantly mediating a proportion of home going, so aspire is significantly mediating a significant amount of home's effect on achieve, and aspire is significantly influencing a large amount or significantly influencing the effects of ability uh, on achieve. Okay, because these two values are significant. Now, to make this a little more interpretable to understand how much is being uh, influenced, we can look at these total effects. Here's the total effects portion of the output. And we can form a ratio of the indirect effect to the total effect. So the indirect effect of home on achievement, as it's mediated by aspire, we divide 0.506, the indirect effect, by the total effect, 0.567. And so when we form that ratio, that comes to 0.89 or 89%. So 89% of the influence of home environment on achievement is being mediated by aspire. We can also look at the effects of ability on achievement as it's mediated by aspire. And so we find our indirect effect is 0.235 and our total effect is 0.920. So 0.920 divided into 2, or 0.235, is 0.255, or 25% of the influence of ability on achievement is being mediated by aspire.